Generative artificial intelligence, Gen AI, is essentially a subset of deep learning. In deep learning, models are typically divided into two primary types: discriminative models and generative models. Discriminative models classify data into categories or predict continuous output results, focusing on distinguishing between different classes or labels. They can predict values like the relevance of content, focusing on telling different document types apart. Examples include logistic regression, SVMs, CNNs, and BERT, which aim to differentiate classes without generating new data. All AI models used at Abbey for document processing purposes are discriminative models. They have been trained on a vast amount of publicly available documents, as well as synthetic data, to classify document types, machine-readable codes, data fields in documents, printed symbols, and handwritten characters. While these models prove to achieve high accuracy in distinguishing between elements, they cannot create any new content. Generative models are the second predominant deep learning model. These models learn the data distribution. This understanding allows them to create new, similar data points. Generative models such as GANs, VAES, and GPTs produce unique outputs by capturing the underlying structure of the data. Applications range from creating text and images to generating audio, making Gen AI useful in content creation, simulation, and unsupervised learning. While discriminative models can distinguish between cat and dog images, generative models can create an image of a cat or a dog, according to your request. In essence, discriminative models answer the question, what class does this input belong to? While generative models, what data could represent this class? Gen AI specifically creates new content by learning patterns in large data sets, enabling it to generate human-like responses, original images, music, and more based on the features it has learned from existing content. Gen AI models are divided into types based on the content created. There are generative text, image, audio, and video models. Generative text models are often correctly referred to as large language models. LLMs are trained on massive data sets of text, enabling them to understand and generate human-like language. Examples include OpenAI's GPT, like GPT-4, Google's BERT, and Meta's Llama. These models excel at tasks involving language comprehension and generation, such as producing coherent text, answering questions, and creating summaries. However, while most generative text models are indeed LLMs, not all LLMs are necessarily used strictly for generative tasks. They can also be fine-tuned for discriminative tasks like classification or sentiment analysis. Generative image models such as DALL-E, Midjourney, and Stable Diffusion focus on producing high-quality, unique images from text prompts or based on specific image styles. They are trained on extensive data sets containing various visual features, enabling them to generate new images that reflect learned styles, subjects, and compositions. These models are widely used in digital art creation, product design, marketing, and even virtual reality, where unique, visually engaging content is essential. Generative audio models produce realistic sounds, voices, or even entire music compositions. For example, text-to-speech models convert text into spoken language with lifelike intonation and pitch, used in virtual assistants, audiobooks, and accessibility tools. OpenAI's Whisper and Google's WaveNet are popular examples of TTS models. Music generation models like OpenAI's JukeDeck and OpenAI's MusiNet can create new musical compositions in various styles. These tools are widely used in background music production for media, advertising, and content creation. Voice cloning models replicate specific voices, enabling applications in personalized assistance or media production. Voice cloning technology is used by tools like Lyrebird, Descript, and 11 Labs, where it helps in creating lifelike voiceovers or narrations. By the way, this voice isn't natural. It's a digital recreation of mine made possible through text-to-speech innovation. Pretty cool, isn't it? Generative video models synthesize new video content, often from textual or image prompts, enabling high-quality and creative visual storytelling. This includes deepfakes, leveraging GANs, that is, generative adversarial networks, These models create highly realistic manipulated videos, often used in entertainment for computer-generated imagery, known as CGI, or in media for historical recreations. Animation and scene generation models generate animations or complex video scenes based on brief prompts or descriptions. Tools like Runway ML enable content creators and filmmakers to produce effects, animations, or even complete scenes, streamlining content production. Synthetic reality and augmented reality, or AR, leverage video models that are also used to create real-time interactive scenes for augmented or virtual reality experiences. These technologies, such as virtual staging or immersive training environments, enhance user engagement in retail, education, and gaming. So, generative AI models are specialized tools that create diverse content based on their focus area. Text models like OpenAI's GPT generate human-like writing and summaries, while image models like DALL-E produce unique visuals. Audio models synthesize speech, music, or voices, and video models enable animations and immersive, augmented reality scenes. These technologies enhance creativity and productivity across industries, from content creation to interactive media.